In this lecture, we're going to see how we can create and use our own namespaces. And the namespace is really put in place to protect you from multiple definitions for a function. Let's look at an example here. Here we have a few functions, and the two functions are called add, and two functions are called sub for subtract. And we want to have all these functions in place. But one thing you should notice that is going to trip us off is that we have the same signature for the same function name. If you look here, the add function has a return type of double, it has two parameters of double type, and we have the same thing here. If we try to compile this code, we're going to get a compiler error saying that we are redefining the add function here, and this is going to be bad. So sometimes you want to have different definitions for the same function. For example, notice here we have different implementations for our add function here. One is just going to add the parameters, and the other is going to do some adjustment on the sum that we come up with here. And suppose this is something really useful for your project. If you want to do this, you're going to get a compiler error and you're not going to achieve your goal. Namespaces are a technique or a facility we have in C++ to allow us to do something like this. And the syntax to declare a namespace is really simple. You say namespace, you say the namespace name, and then you put a pair of curly braces. Inside those curly braces, you're going to put whatever you want to constrain to that namespace. For example, the first namespace here is called no weight, meaning that we're not doing any adjustment on the sum here. And we have a second one, which is called weight. Inside, we're going to put the second version of our add function, and we're going to do our adjustment here. If we set up our code like this and try to compile the code, it is going to compile and work fine. Because now C++ is going to see that the first add function here is living in a different place than the second add function here, and the C++ compiler is going to accept this. We have the same setup for our sub functions here. We have a no weight namespace and we have a weight namespace, and this is going to work. Another thing you can do with namespaces is use them to split your code across declarations and definitions. For example, here you see our namespace weight. It is going to be spanning different blocks. The first block is right here, and the second block is right here. And the C++ is going to accept this, and the C++ compiler is going to do whatever magic it needs to do to keep track of this namespace in this file here. So we're going to have our declarations on top here, and we're going to have our definitions down below, and this is going to work. Once we have the namespace set up, we can use it in the main function. And here is a simple example, for example, using things from the weight namespace. All you have to do is prefix whatever you want to call with the namespace name and a pair of colons here. And this is going to tell the compiler I want to call the div function, which lives in the weight namespace. Okay, so this is really it. This is how you set up your namespaces. You say namespace, you say the namespace name, you put a pair of curly braces, and inside you put whatever you want to leave in the namespace. To use the namespace, you say the namespace name like you see here, you put a pair of colons, and then you say the name of the function or the name of whatever it is you want to access through this namespace here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is creating namespaces. We're going to grab our template files pretty quick, and we're going to put them in place. And we are going to open this in Visual Studio Code by dragging and dropping here. This is going to open our project. We have the main CPP file. We can clean it up a little bit. Let's remove this. And we close the left sidebar here. We are going to put in our starter code, and it is nothing really complicated. We have a variable, which is going to be our adjustment. We have the add function, which is going to just add the parameters we pass in here and return the result. And we have another add function, which is going to not only add, but it's also going to do an adjustment and give us the result. But as you already know, if we try to compile this, this is not going to work because we have the same function defined twice in our program. So for example, if we go down here and say add, and say 2 and 3, for example, and I try to compile this program, we're going to pass this through GCC. You're going to see build finished with errors. And the problem is we are redefining the add function here, and C++ or C++ compilers are not going to allow this. So we really need a way to tell the compiler that these are different functions or functions for different purposes. And we can use namespaces to do that. So for example, we can set up a namespace that says that the first function here has no adjustment and that the second function has an adjustment. And we can say namespace, and we can say the namespace name here, we can say adjust, we can say this, and then we're going to take our function here, or we can call this no adjust, and we can grab our function here and put that in our namespace, and we can align these things a little bit better. And we're going to do the same thing for the second function here. We're going to move that in a separate namespace, and the namespace is going to be called adjust. Let's do that. We're going to say namespace, and the namespace name is going to be adjust, and we're going to grab our function here and move that in our namespace. Let's do that, and we're going to move things a little bit to the right. And now the C++ compiler is not going to be confused if it sees these two functions, even if they have the same signature. The C++ compiler is going to say, this one lives in a different namespace than the other one, so they are different. But we still have a problem. How do we call these functions here? Because if we try to compile this program without calling the function, you're going to see that the build is going to be good. But if we come here and say add 2 and 3, for example, we're going to get a compiler error because the C++ compiler can't figure out which version of the add function we want to call. Do we want to call the one from the no adjust namespace, or do we want to call the one from the adjust namespace? The C++ compiler doesn't know. C++ provides a syntax we can use to say which namespace the name we want to use lives in. And all we have to do is say the namespace name in front of your function. For example, we can say adjust and say : This is going to tell the C++ compiler, this guy wants to call the add function living in the adjust namespace. And if we grab the result, for example, let's say double result, and print this out, we can say stdcout result. This is going to work just fine. Let's build this, and we're going to pass this through GCC like we always do. The build is good, but now we can bring up a terminal and actually run this program and see it doing its magic. We can clear and run rooster, and we're going to see that our sum is not 5. It's going to be adjusted because we are using the adjusted version of the add function. If we want no adjustment and if we want to get a 5, we can use the no adjust namespace. We can do that. And if we build now, the build is going to be good, but we can clear and run rooster. We're going to see that result is 5. This is really how you can declare a namespace, put stuff inside, and then use that namespace like we see here. Okay, now that we have seen how to set up namespaces, I want you to see that it is also possible to split things across declarations and definitions using namespaces. So for example, we can set up our multiplication and division functions here. For example, we can go down and say namespace and say no adjust. And we're going to set up another namespace and call that adjust. And inside, we're going to put our declarations for the multiplication and the division functions. So we can go down and say double mult. And we're going to say double x and double y because that's what we have been using all along for the other functions here. And we're going to say double div, and we're going to divide x and y. Let's do that. We can actually grab the same declarations here and use them in our adjust namespace because the signatures for the functions are really the same. The differences are going to come up when we do the actual definitions for the functions. Now that we have the declarations in, let's say that these are declarations. We can go down and put in the definitions for these functions here. We can grab the entire thing here, and we're going to adjust this a little bit. We can go down below the main function, or if we want, we can even put this in a separate translation unit. Linkers are going to be smart enough to go and pick these things up wherever they live in our project. But we want to keep things simple in this lecture, so we're going to put this below the main function here, and we're going to use them. So now we have these things, and we want to put in the definitions. Let's do that. We're going to return x multiplied by y here, and we're going to return x divided by y, and we're going to return the result of dividing x by y here. Let's do that, and this should do it. We're going to go down and do the versions that do adjustment to our result. We're going to multiply x and y, and then do the adjustment. The adjustment is just going to be minus adjustment. We want to keep things simple here. So we're going to use this, and then we're going to do the division and do our adjustment. We're going to return x divided by y, and then we're going to do our adjustment here by subtracting our adjustment value. Let's go back and see that we did divide correctly. This looks really cool. So now we're going to try and use our multiplication and division functions. If we change the no adjust here and use mult to multiply, let's do that. This should multiply 2 and 3, and we should get the result in this variable here and print this out. So we expect to get a 6 because we are using the no adjust version of our multiplication function here. And if we go down, we're going to see that this is just going to multiply x and y and return the result. We can build this through GCC like we always do. You're going to see the build is good. We can clear and run rooster, and we're going to get a 6. If we go back in main and say adjust, we're going to adjust the result of multiplying 2 and 3, and we're going to get something less than 6 because all we are really doing is subtracting the adjustment from our multiplication here, and this is going to be what we see when we run the application here. We're going to build with GCC. The build is good. We can clear and run rooster. We're going to get a 5.2 something, and this is what we expect. We can even use the division function. For example, we can take a 12 and divide that by 3 here. And if we do the adjustment, we're not going to get a 4. We're going to get something less than 4 because we are subtracting from that. Okay, so let's build again. We're going to pass this through GCC. The build is good. We can clear and run rooster. We're going to get 35 something. What is going on here? Let's go back and see what we did in main. We are actually multiplying. We're not dividing. Let's divide, and we're going to do the adjustment. So let's run this through GCC. The build is good. We can clear and run rooster. We're going to get a 3 point something, which is what we expect. If we don't do any adjustment on our division and say no adjust, this is going to divide 12 by 3, and we're going to get a 4 as the result, and we're going to print this out. Let's do this. We're going to run this through GCC. The build is good. We can clear and run rooster. We're going to get a 4, and this is really what we expect. This is really all I wanted you to see in this lecture, showing you how you can declare your own namespaces. The syntax is really simple. You say namespace, you say the namespace name, you put a pair of curly braces, and inside those curly braces, you're going to put whatever you think should live in your namespace. It is even possible to split things between declarations and definitions and really use your namespace however you see fit. We are going to stop here in this lecture. In the next one, we're going to see how you can split your namespace across different files. And we're going to extend the idea here and use our namespaces to englobe class types. So go ahead and finish up here and meet me there.